Okay, now we are going to start with the chemical properties. Okay, so here we have few chemical properties. Chemical properties are basically considered as a chemical reactions of a metals. First reaction is with cold water. And when the reaction with the cold water occurs, when metal reacts with the cold water, metal hydroxide and hydrogen gas forms. The second reaction is with the steam. So steam is the vapor form of water. So when metal reacts with the steam, metal oxide and hydrogen gas is formed. Khatija, am I audible to you as well?
Yes, sir.
Okay, what is happening over here? I don't know. Okay, Khatija, I'm okay. That's fine. Yeah. Just give me a minute so you guys can practice along with me. Okay. So these are the four kinds of a chemical reactions that metal undergo. So whatever the chemical reaction a substance undergo is considered as their chemical properties. Okay. So when a metal reacts with a cold water, the products are metal hydroxide and hydrogen. That's what you have to remember. In the similar way, when metal reacts with the steam, steam is the vaporized form of water, we will get metal oxide and metal oxide and hydrogen. When we react a metal with a dilute acid, the products are salt and hydrogen gas. So see, whether metal reacts with cold water or steam or acid, every time one product is a hydrogen gas. The other product, in case of cold water or in case of a water, we get metal hydroxide. In case of steam, we get metal oxide. And in case of acid, we get salt. And that fourth reaction is when metal reacts with oxygen. In this case, we will get a metal oxide. Now we are going to discuss each of these reactions individually. Okay, first copy this down, then we will discuss further. Assalamualaikum Zainab, how are you?
Walaikum salam. I'm good. How are you, sir?
I'm good. So after where we have ended, we have started from just here, just copy this down. There are 4 different kinds of chemical reactions that metal can undergo, and we are going to discuss each reaction individually, okay? Okay. Yes, Khatija, are you done as well?
Yes, sir. Done.
Okay, Zainab, can you take the screenshot? Okay, so now we are going to discuss the first reaction of a metal, that is with a cold water, right? So we know what are the products with water. What are the products?
Metal hydroxide and the water.
Metal
Sorry,
hydroxide and hydrogen, right? So here are a few reactions that we are going to observe. So if you see these reactions, let's have a look over the how these reactions take place. When we react potassium with a cold water, the reaction is vigorous, which means that this reaction is very fast, very rapid, right? This reaction is very fast. So with the term vigorous is used for a reaction which is more than a fast, which can actually be a little explosive. Then with sodium, it's very fast. With calcium, it's fast. With magnesium, it's very slow. And with zinc, no reaction. So by looking at the attitude of these metals with the water, we can conclude about their reactivity. We can say, after observing this, that potassium is the most reactive one. Then sodium is less reactive than potassium. Then calcium is less reactive than sodium. Magnesium is less reactive than calcium. And zinc is less reactive than magnesium. Is this understandable?
Yes.
Yes, Zainab?
Yes, sir.
Now we have the specific observations of each of these reaction. When we put potassium in water, potassium starts to float on water. And as we know, the hydrogen gas is formed. You know that hydrogen gas is highly flammable gas. Okay. So due to the uh, vigorosity of this reaction that the hydrogen forms is catches fire. You will observe a fire on the surface of water, on the above on the surface of water. In sodium, we just observe that sodium, when we put the sodium, it floats on the water. Then calcium dissolves readily in water. And with magnesium, there are bubbles that can be seen on the surface, but very slowly. So see, these are the specific observations. Okay, now tell me, when the reaction occur, we will get metal hydroxide and hydrogen, right? Okay, so metal, there could be a metal and that metal have some charge on it. We will easily going to figure out that charge by periodic table. Okay, I think my screen stops. Okay, what is the formula of hydroxide ion, Manahil? What is the formula of hydroxide ion? We did it in bonding. Yes, Zainab, can you tell me the formula as well? The formula of hydroxide ion? Am I audible to you guys?
Yes, sir.
Okay. I think my screen stops. Okay, very good, Khatija. Why you don't remember this? Yes, Zainab and Manal. Assalamualaikum. Sorry, you? Okay, and what's your name? Arisha. Aisha. Okay. OH minus. Okay, you guys have to recall the formula, remember the formula of polyatomic ions specifically. So for time being, you have to memorize, you have to recall the hydroxide ion have a formula of OH with a -1 charge. Okay, in which grade are you? Okay, you are going to appear in 2024. Okay.
Sir,
Yes.
I didn't get the result of the first reaction. Like the it will float and the hydrogen is produced. Like how will it be?
Uh, can you repeat?
Like when the potassium react with the water, so the result was that it will float and there will be. It was something written like hydrogen. Something will happen with hydrogen will it produce. So I didn't get that how it.
Actually, the thing is, just give me a minute. Okay. Am I still audible to you, Khatija and Zainab?
Yes.
Yes, sir.
Okay. 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 Is my screen shared? Okay. So, Khatija, what will happen over here? That when we put the potassium metal on water, so it is very reactive. It starts floating on the surface of water, and this reaction is so vigorous, and there is so much heat that is produced, which causes the sodium metal also floats on water. But the thing is that here the heat energy is not that enough to make hydrogen to catch the fire. So from this we can conclude that reaction with potassium is more reactive than the reaction with sodium. Now is this understandable?
Yes, it means that it is more reactive. That's why it can easily catch the fire.
Yeah, because of the higher reactivity, it is catching the fire. And when we look at calcium, calcium just dissolves readily in water. It doesn't float like sodium, so it is less reactive. And with magnesium, we observe the reaction is very slow. Okay. Now, if you see that magnesium hydroxide have a two ions, one is hydroxide ion, oh sorry, metal hydroxide have a two ion, one is hydroxide ion and the other ion is metal ion. So we know the word equation whenever any metal reacts with Okay, so there are two ions in metal hydroxide. One is a metal ion. Its charge we are going to figure out from the periodic table. And one is the hydroxide ion. And for that hydroxide ion, you must remember its formula as it's OH with a -1 charge. So this is the polyatomic ion, and polyatomic ions are not provided in periodic table, so you always have to memorize them. Okay. Okay. Now, with the help of this word equation, we can able to make all of these equations. So you have to remember this thing, that whenever metal reacts with water, what will get? Metal hydroxide and hydrogen. And these four metals reacts with water, and when we try to react zinc with water, it does not react. Is this understandable?
Yes.
Yes, Khatija and Zainab? Okay. Now, let's see how we will make the equation. First equation I will be making, and then the rest of the three equations you guys will make. Okay. So, we know that our one product is hydrogen gas, right? Now we have to make the formula of metal hydroxide. In first reaction with what is our metal?
Potassium.
Yes, potassium. So the reaction, the metal hydroxide will be potassium hydroxide. So if you see potassium, where it is present? It is present in
Group 1.
group 1, right? You can easily see that it is present in group 1. So if it's present in group 1, what charge potassium have?
+1.
+1, right? So this will help us to make the formula. So if we will make the formula, we know potassium have a +1 charge and hydroxide ion have a -1 charge, right? So when both the ions have a same and opposite charge, the formula will always be written by just combining both the ions. Okay, so this will become the formula. If, for example, potassium have a +2 charge and OH minus have a -2 charge, then again the formula would be same. But for instance, if potassium have a +2 ion and OH have a -1, then the formula would be, then in this case, we move the value to the subscript of the other ion. So the 2 moves to OH and 1 moves to K, then the formula would be K OH twice. Okay, so we got the formula. Now we have to balance the equation. See, how many potassium atoms are over here?
1.
1. And how many potassium atoms are over here?
1.
1. Okay. How many oxygen atoms are over here? Yes.
1.
1. How many oxygen atoms are over here?
1.
1. How many hydrogen atoms are on the reactant side?
2.
2. And how many hydrogen atoms are on the product side?
3.
Sorry, 3. 2 over here and 1 over here. So hydrogen is unbalanced. So it means we have to balance the hydrogen. Okay. So we have a 2 hydrogens over here. So what we can balance this equation in 2 ways. One way is, if I just put a half over here, the equation is balanced. If I put a half before H2, that makes, now how many hydrogens are over here? Only 1, because when you multiply half with the 2, what you will get?
1.
Half times 2, you will get 1, right? So we got 1 hydrogen over here and 1 hydrogen over here. Now the equation is balanced. Is this clear? Now in the similar way, you can make the equation for sodium. If you look sodium is also in group 1. So the charge of sodium is also +1. Okay, so now make the equation for sodium when sodium reacts with water. Yes, Janam, is this clear? Yes, Khatija, is this clear?
Yes, sir.
Aisha, did you understand? Manahil? Okay. Now calcium is in group 2, so calcium have a 2+ charge, and you know hydroxide have a -1 charge. Magnesium is in group 2, magnesium have a 2+ charge, and hydroxide ion have a -1 charge. And then zinc, you have to remember the charge of zinc, it is always 2 positive, and hydroxide have a -1 charge. Okay, for zinc we don't need because the reaction didn't take place, right? Yes, Zainab, what you are asking? Okay, now you guys have to. No, we can't. It stays H2 only, but we put a coefficient in before out any one of them to balance the equation. But we can't change the formula. We can't make H2 as H3. Okay, H2 is the formula of hydrogen, but we put the coefficient to balance the equation. So now your task is you have to complete all 3 equations. Okay, I have provided the chart. First, complete the equation, and after completing it, balance it as well. I will be back in 3 to 4 minutes. Then I will do it. Okay, how many topics you have covered yet? Actually, how many topics you have covered yet? Hmm? None of them. You are finding so late. Hmm? Okay, really stress. Are you done with the all equations? Why you need H? Because hydroxide has a wedge. So why you overlook to see? Yes, Zainab and Khatija, are you done with the equations?
Yes.
Now have a look. We know the format for this kind of a reaction. Whenever there is a metal and a water, what we will get a metal hydroxide and hydrogen. So for when sodium reacts with water, what will happen? We know hydrogen
Sodium
gas will
hydroxide.
form H2 and sodium hydroxide. So we have just seen in the periodic table, sodium belongs to group 1, so it have a +1 charge, and OH have a -1 charge. So if both have a +1 and a -1 charge, what we do, we just combine the ions, and when we combine the ions, the formula would be NaOH. And remember, these hydroxides are water soluble. So we always get aqueous. They always become aqueous because they are forming in water. Okay, so sodium hydroxide would form. Now the other way of balancing this kind of equation, in the first we have just put it half before H2 to make two hydrogens on both sides, right? But if you see on the product side, how many hydrogens I have?
3.
3. And on the reactant side, how many hydrogens I have? 2. So the best way, if you are you face any problem or difficulty with the fractions, what you will do, you see on the product side the hydrogens are in odd number, right? And on the reactant side the hydrogens are in even number. So make the hydrogens on the product side also even. And how I can do that? If I put a 2 over here, if I put a 2 over here, that 2 is going to be multiplied with each element, with sodium, with oxygen, with hydrogen. Now this 2 make these hydrogen 2, and there are 2 more hydrogens. So in total, how many hydrogens are on the product side? 4.
4.
To balance it, I will put a 2 over here. If I put a 2 over here, we will get a 4 hydrogens on this side as well, right? Now see, hydrogens are balanced on both sides. Is this clear? Yes, Zainab, is this clear to you as well?
Yes, sir.
Okay, now if I put a 2 over here, that 2 multiply with this oxygen, that makes this oxygen 2 as well. And here, this oxygen also becomes 2 because I have put a 2 over here. So hydrogens are balanced on both sides, oxygens are balanced on both sides. Now we will left with the sodium. How many sodium over here? 2. And how many sodium over here? 1. To balance it, what I have to do? I have to put a 2 over here. So the first equation with the potassium and the second equation with the sodium, both can be balanced in either way. If with potassium, instead of putting a half over here, if I put 2, 2 and 2, this is the get balanced. And instead of putting 2, 2 and 2, if I put a half over here, this is also balanced. So we can balance these two equations in either way. Both are considered as correct. Is this clear? Yes, Manahil? Yes, Khatija?
Yes, sir.
Zainab, is this clear to you as well?
Yes, sir.
Okay. Now have a look at the next two equations where we have the metals which are forming a ion with a +2 charge, right? So the one product is again going to be same, hydrogen and hydrogen, right? For the other product, as you see over here, that now they have a different charges. So this 2 moves to the subscript of a hydroxide and 1 moves to the subscript of calcium. So there is, whenever there is a 1 in the substrate, we never write that 1. There is no need to mention that 1. So the formula would be Ca and OH twice. And for magnesium hydroxide, the formula would be same. You made the correct formula? Yes, Khatija and Zainab, you both also made the correct formula?
Yes, sir.
Yes, sir.
Is this clear now? Okay, now have a look. How many calcium are over here? 1 and 1. How many oxygen are over here? 1. And how many oxygen are over here? Yes?
2.
2. Because outside the bracket, that's 2, which is actually multiplying with the hydrogen and the oxygen. So there are 2 oxygens. So to balance the oxygen, what I have to do? I have to put a 2 over here. If I put a 2 over here, the oxygen on the reactant side becomes 2, right? And oxygens here also becomes 2. So oxygen are balanced now. Now, can anyone calculate the hydrogens on the product side? How many hydrogens are on the product side? 4. So if I put the 2 before water, that makes hydrogen 4 on the reactant side as well. So my equation got balanced just by putting the 2 before water. So the equation with the magnesium is also similar with the calcium, because we are getting the same formula of the hydroxide, 1 magnesium ion with 2 hydroxide ions and 1 calcium ion with the 2 hydroxide ions. So this equation is also be balanced in the same manner. If I put a 2 before water with the reaction of a magnesium with water, we will again get the equation is balanced. Is this clear? Yes, Aisha?
Yes, sir.
Teacher, Zainab, if any one of you have any question, do ask. Okay, now the general observation of all of these reactions. Normally, these are the observations which examiner asks. So see, we have a metal in all of these cases. What is the state of metal? In which state this metal is present?
Solid.
Yes,
Solid.
solid. Thus, S in the subscript represents its state, and we are putting it in a liquid. And in the product, is there any solid?
No.
No, right? If you guys see, there is no solid in the product. So from this, what we can conclude that the solid finally is going to disappear, that it gets dissolved. So our one observation will be the solid disappears. Is this understandable? So the first observation will be solid disappears. The second observation will be bubbles of a colorless gas. Okay, so see, a hydrogen gas is forming in all of these cases, right? And hydrogen gas is forming in the solution because the compound that is formed is aqueous, which means that it is soluble in water. We are getting the solution. So whenever a gas is formed in solution, what we will observe? We will observe bubbles, and hydrogen has no color, so we are going to observe bubbles of a colorless gas in all of these reactions. So what examiner do? Examiner connect the test of the hydrogen gas with this. So you must remember this test, that to test the hydrogen gas, what we do, we introduce the lighted splint at the mouth of the test tube like this. And as the gas comes in contact with the fire, with the flame, you are suddenly going to observe a pop sound, pop. If this happens, then this confirms the gas is hydrogen. That is the test for hydrogen gas. If we have to confirm that the gas is hydrogen, so that is the test. You will write in that test, you will write lighted splint, and the observation will be pop sound. Okay. The other thing that you are going to observe, that energy is released. So when the energy is released, the container in which, or the beaker in which the reaction taking place gets warmer. So from this, what we can conclude, that the reaction is exothermic. The energy is being released during the reaction. Is this understandable?
Yes.
Okay, now the colorless solution is alkaline because we are getting a metal hydroxide. So remember, all hydroxides are alkali. And to test the alkali, what test we do? We always dip a red litmus paper. And on dipping the red litmus paper, if it turns blue, it indicates that there is an alkali. So these are the general observations that you are going to observe with all of these reactions. Is this clear?
Yes.
Yes, Zainab?
Yes, sir.
Yes, Aisha? Manahil? Okay, note it down quickly. Due to some internet issues, we face some problems in the class. Okay, after this, we have a next reaction, that is reaction of metal with. Check. We made the list initially.
So how many chapters we covered?
We have covered the states of matter, atoms, elements, compounds, atomic structure, and bonding. We have covered those 4 chapters. Now we are on metals. In the last class, we have started metals.
Sir,
Yes.
these हमने ऊपर लिखे हैं like after the reaction like bubbles on the surface and the hydrocarbon gas and all that. So these are the I mean that these are the physical properties.
These are the specific observations that we are going to observe in each reaction, the one we have written over here in the black. And these are the common observations which you are going to observe in all of these reactions.
And sir, one last question that in the sodium and potassium, it is written floats on the water. It means sodium and potassium will float in water, right?
Yeah, they are float on water when they are reacting, and
Okay.
as they used up, they will disappear. Yes, Zainab, we done states of matter, that is also called kinetic particle theory. Then we did the atoms, elements, and molecules. Then we did atomic structure, and then we have completed bonding. And now we have started metals. Okay. Is everybody done?
Yes.
Yes, Zainab?
Yes, sir.
Okay. Now we are going to discuss the reactions with steam. So, if you see that when we use the cold water, sodium and potassium and calcium are reacting fast with the cold water, right? So that's why we didn't try to react with the steam, because steam actually forms at very high temperature. So when they are reacting very vigorously and fast with the cold water, so they are going to react with the steam explosively. So for the safety precautions, we don't let them react with the steam. So if you recall, with the magnesium, the reaction of cold water is very slow. So we are going to react magnesium with the steam, and the steam, the reaction is very vigorous. Then zinc doesn't react with the cold water, but with the steam it reacts fast. And when we observe iron, the reaction of iron with the steam is relatively slower. And when we observe, copper doesn't react with the steam as well. So it means now we get that zinc, iron is less reactive than zinc, and copper is even less reactive than iron as well, because it is not reacting with steam. So how you can differentiate between steam and cold water? If you check the previous equations, we have written L in the subscript, which is saying that it is liquid, so it is water, and here it is gas, which means steam. So in this case, we got a different product. When there is a water, we was getting metal hydroxide, and now we are getting metal oxide. Is this clear to everyone?
Yes.
Okay. Yes, Khadija. So one product will be hydrogen in all of the cases. So hydrogen gas is formed, it always form, right? Now we have to make the oxide. So we have to work on the formula. So if we look at the position of oxygen, oxygen is in group 6, right? So if it is in group 6, then what will be the charge on oxygen?
2 minus.
2 minus. Okay, it have a charge of 2 minus, and these metals have the charge of plus 2. So magnesium is 2 plus and oxygen is 2 minus. I am just writing this for rough work, so you can make the equation. You will complete the equation by making the formula and then balance the equation. That is your task. Do it quickly in all 3 equations. So what will be the formula, because both have same charges? So the formula becomes, yes, what will be the formula?
Magnesium oxide.
MgO for magnesium oxide, and it formed as a solid only. Okay. And then we will get zinc oxide, ZnO, as solid, and FeO as solid. Now see, is there a need of a balancing these equation or not?
No.
All the equations are already balanced. If you see, there is a one metal on both sides, there are 2 hydrogens on both sides, and there is 1 oxygen on both sides.
Sir,
Yes.
Fe will not be 3 plus.
Yeah, in a specific condition, iron becomes 3 plus. Most of the time, it will stay 2 positive. So whenever you are making a general equation and examiner doesn't provide you any information, keep it 2 plus only. Okay. So
Yes.
everybody get it there? Now the third reaction is metal with dilute acid, and we will do it in our next class. Just write the word equation for today. And Zainab, do memorize the polyatomic ions, and Manali do as well. Did you understand? Okay, are you looking for a demo or you already taken the admission? Yeah. Okay. That's fine. So if you have any confusion, anything you need to ask. Yes. If you have any confusion or you need to ask anything.
Sir,
Yes.
मेटल रिएक्शन विद स्टीम में हमारे पास इंडिविजुअली रिजल्ट्स नहीं बताएंगे हम, लाइक जैसे हमने ऊपर बताए थे.
Can you repeat again, Khadija?
सर लाइक मैटर द रिएक्शन ऑफ द मैटर विद द स्टीम में हम फिजिकल वो नहीं बताएंगे, लाइक जो इंडिविजुअल फिजिकल हमें क्या नजर आ रहा है आफ्टर द रिजल्ट जैसे एग्जाम में ऊपर बताया था.
No such observation because see there is a solid on reactant side and there is a solid on product side as well. Okay.
Sorry sir, I was not able to hear you before.
So there will be no such kind of observations that you can see. Beside this, that a silvery gray metal turns white solid. Okay.
Okay.
Yes, Khatija, are you done?
Yes.
Yes, Zainab.
Yes, sir.
Okay. So we will continue from here in our next class. Okay.
Okay.
Okay. Take care, everyone. Allah Hafiz.
Allah Hafiz.
Allah Hafiz.